Hello everyone, Dr. Ziata here. This video tutorial is about 2D steady-state heat transfer analysis in ANSYS Workbench. Specific problem is steady-state conduction through plate. The problem statement is a square plate shown in figure has a thermal conductivity of 15 watt per meter per degree Celsius. The top side, this top side, the top edge is maintained at 250 degrees Celsius and other three sides are maintained at 40 degrees Celsius. So those four sides, they are maintained at 40. Determine temperature at center of the plate, so somewhere here, and plot temperature distribution from top to bottom passing through the center and the temperature distribution midway between the plate. This problem is modified problem taken from chapter 13, Heat Transfer and Mass Transport, a first course in the Finite Element Method, 6th edition by Daryl Logan, and that is a problem 13.24. So the steps to use in ANSYS, the first one to select a project, the second one engineering data, then geometry, and in geometry analysis type, design modular geometry, then model, and that is geometry. And these are steps which I'll follow for this analysis in ANSYS Workbench. The first step is project and start project in Workbench. So this one is layout of ANSYS Workbench, and here are analysis systems. And in analysis system, that steady state thermal I'm going to use. So just right click on steady state thermal. So you will get that steady state thermal and then that steady state thermal. Now that one, so there are 7 steps here. So the first one is already done. So that a project in the project schematic, a steady state thermal project is being started. You can save that project any way you like. So file, save, and I'm going to save that in some folder and I'm plate steady state conduction. So once you have started steady state thermal project, then the next one is engineering data. And for engineering data, you need to add material. And for the material, thermal conductivity is 15 watt per meter per Celsius. So for that one, double click on engineering data and a new window will open. Okay, so by default, there is a structural steel, but this one I am going to use that material. So a new material is being created and then the question mark on that. So to that material, isothermal conductivity need to be assigned. So once it is assigned, and then isothermal conductivity and the units are watt per meter per degree Celsius. I'm going to select and the thermal conductivity is 15. So now this material is created here you can see. Okay, I'm going to uncheck that structural steel material and then save it. So you can close that window or you can leave it as it is. Next step in geometry, need to select analysis type 2D. So here, click on geometry and in the here in the properties, advanced geometry options, to select here 2D. And then in this geometry, start a new design modular geometry and then sketch, dimension, concept, and generate. So these are the sketch, dimension, concept, and generate. So Here, right click on geometry and new design modular geometry. So that is a design modeler. So the first step for design modeler is need to change the units because the units are in meter for that plate. So I'll select that meter. So the plate is square plate with dimension 1 by 1. So in the design modeler, I want to sketch that in XY plane, and that is XY plane. So you can sketch like as in 3D, or you can turn it to 2D as well. So with this one, you turn it to 2D, or otherwise you can draw that in XY plane as 3D. So for that, you have in the design modeler, there are two tabs, main tab. One is modeling. So you click there, and then in the sketching. So in the sketching, you have further five tabs: draw, modify, dimensions, constraints, and setting. So you can go to the setting and then 2D grid and then snap. And the major grid spacing, you can keep it as 1, and then minor steps per major. So you can go for 2 or 5 or 10 depending upon that. So now you can see that is a grid there, and with the mouse wheel or with the trackpad, you can adjust the distance. So then in the draw, I can use that rectangle, and for that rectangle, so it can be drawn with arbitrary dimensions. Okay, so that rectangle is being drawn with arbitrary direct dimensions. So I'm going to switch off that grid, and then I can go to the dimension and then display dimensions, and in general that is H1 and that is V1. So H1 is 1.5 meter, so just change it to 1 meter. So now that is the rectangle. So I want to place it anywhere. So for that one, you can modify and you can use that drag option. So you can use the drag option. So the center, it is on the, its center is at the origin. Or otherwise, you can do other way if it is anywhere like that way. So you can set constraint and then you can apply symmetry about x-axis like that, and then you can also apply that symmetry about y-axis. So now the sketching is done, and again in the model, so sketch, you give dimension, and then in the concept, you need to create that one. So here, once here the sketch is being created, so just click on sketch, go to concept, and then surfaces from sketches. Okay, so you can see that here surface SK1 is being created. So then apply. So it's a base object not selected. So for that one, you need to click on sketch and then it is selected. So once here you have sketch, and now you can generate. So that is now is being generated, and you can see here is the surface body. So I am going to rename that as plate. So in this way, your first step like design modular geometry and sketch dimension concept and generate it. Next step is model, and for that one, Here is the model and double click on model. So it will take some time to open that ANSYS mechanical. So now that is the model. So in the model, you need to first assign material. The first is in the model, then geometry, and then assign material. So for that one, in the geometry, that is a plate, and then material selected is structural steel. So you need to convert that to the material, and then you can check that what is the material. So that is material has just one property. Okay, so that is the first assignment of material. So temperature distribution from top to bottom passing through the center is required. For that one, in the model, need to go to construction geometry and then create a path between 2 points. So for that one, click on the model, and now in the model, here is a construction geometry and then a path. So here you have a path, and for that one, its x coordinates, so both are at the center. So I am going to set y coordinate of the first one right in this above the center, and the other one minus zero point 0.5. So that is there. So you can check that where the coordinate system is, and for that one, so you have created that path, and now you can name it as or just leave that as path. Next step is mesh, and you need to define element size for that and then generate the mesh. So here you can find out that there is a mesh, and, and here use geometry setting, physics preference is mechanical, element order is program controlled, and then I am going to define element size as 0.05. And once it is being assigned, so in the mesh, I can just right click on mesh and then generate mesh, or here you can generate mesh. So then this mesh is generated with an element size of 0.5. Okay, so that mesh is generated with all that default function. Now there is a tick on the model, and the next one is setup. So the next step is setup, and there under the steady state thermal tab, need to apply boundary condition. And in the environment tab, temperature, and then scope, geometry, phase, and then the definition and its magnitude. So here, click on steady state thermal, and once you're going to click on that, so then that is environment. So on steady state thermal, you can go right click and insert temperature, or you can go environment and then insert temperature. So that temperature, I am going to use it for top edge. Okay, so for top edge, and then I'm going to select that. So now geometry selection is applied. So that is one edge top edge is being selected, and the temperature for that one was is 250. So now on the top edge 250 is being applied. And then again the temperature on other, that is 40, and for that one I can go here insert temperature, and then here I am saying that 3 or cold edges, or you can give it name. So I am 3 edges, and for those 3 edges you can see there is a question mark on that. So here the scope is a geometry selection, so I can select that first edge, then here first, then second, and then that is the third one. So you can see that 3 are green, so they are selected. So applied, and it says three edges are selected and the temperature is 40. Okay, so now the boundary condition on the top edge is 250 and other three edge is 40 that is being applied. So like at A there, and then when I click on B, so all four edges are being selected. So the next step is in the solution, need to go thermal and then define temperature for all, and then for thermal temperature at the center, and then thermal temperature along that path. So for that one, here is the good solution, and then click here to insert thermal and then temperature. So that is temperature for whole of that plate. And then the next one, uh, a node can be selected right somewhere in the center, and then again temperature on that need to be calculated. So for that one, here you have node, and that is node right in the center. So here one node selected, and you can see that its coordinates are almost 0, 0, and I'll go thermal and then temperature. So now I'm going to rename that as center. Okay, so then to get temperature along that path, so again click on solution, go to solution here, and then thermal temperature, and then I am going to rename as along that path. And for that one, here, go to geometry selection, and that is path. And then here it says that path name, because the path name is just path. So now it shows there. So that is the path from top to bottom. That is a node selected at the center. And then this is for the whole of that. So now all three, like temperature of the whole plate, then temperature at the center, and then temperature at the path is being selected. So now the next step is to solve that. And for that one, here you can just right click on that and solve, or otherwise you have option there to solve. It will take some time, and you will see all those ticks there. So the last step is to get results, temperature along that node, or you can use probe, and then temperature, you need to plot temperature along the path. So now here you can see these are the temperature contour plots of whole of that plate. Okay, and then that is the temperature at the center. It just is going to show that temperature at the center is 92.5 degrees Celsius, and then temperature along the path. So here that is along the length, and that is the graph. So when once I have created that path, so by default number of sample points are 47, and because the total length is 1, so I want 10 for that. So now for that path, I'll solve it again. So once it is being solved, so you can see there, so the temperature at the top is 250, temperature right in the middle is 92.5, and then 40, and that is the graph for that. So it depends at how many points you want. Like if you want 99 point 100 points for that, so you can change the sampling to 99 and just path to click on path and solve, and now you will have that 100 points for that. Okay, between those lengths. So in this way, that is a temperature distribution. So you can copy that data from here, and then you can paste it, or you can just take extract that one. So this is how uh, you can perform steady state analysis, heat transfer analysis for that plate. Thank you very much for watching. I hope that you like this video, and that is a summary of all all those.